Hello guys, it's Rafi here and you're watching the second part of creating the CICD cluster inside Google Cloud and Kubernetes and with Jenkins. So stay tuned. If you watched the first part of this series, you already know that we decided to create a cluster, a Kubernetes cluster inside Google Cloud to host all the components related to our CICD system. So let's quickly review what is the structure of our Git repository. So what do we have here? As you can see, there is an infra directory, and inside the infra there is a CICD, and below that we have Terraform, and basically all the codes related to creating our Kubernetes cluster is stored here. So it makes sense that we have another directory other than Terraform below the CICD to host all the deployment files or probable Helm charts. Let's create it quickly. Then we wanted to, inside the infra and inside the CICD, we should have a tools, and inside tools, the first tool we are going to deploy is Jenkins. So we have Jenkins here, and then yeah, looks good. So for deploying the Jenkins inside the Kubernetes, we have two standard approach, right? The first approach is just by using the deployment file provided by Jenkins documentation itself and just apply it against the cluster. And the second option is going with Helm, right? There's a Helm repository, you can add it to your local Helm, and then you can just deploy the Helm chart inside your Kubernetes cluster. We don't want to go with the second option, and the reason is that when you're trying to deploy the Jenkins using Helm, there are so many configurations, there are so many variables that should be assigned, because basically all the configuration related to Jenkins can be set in the first initialization using Helm chart, and there are so many variables there. We don't want to go through all of them. So in our case, it just makes it a little bit more complex instead of just providing the simplicity for us. For deploying the Jenkins, I will continue with the deployment file itself. Let's quickly review the deployment file provided by the Jenkins documentation and go through the configuration here. As you can see, the first part is a cluster role. We need this cluster role. Why? Because basically we want to grant permissions. We want to grant enough permissions for Jenkins controller to create a new pods and set it as agents, connect to agents, and then deliver the task, and then kill the pods when it's finished, and blah blah blah. So many interactions inside the Kubernetes cluster, and for that we need to grant it, right? So we create the cluster role here, and let's say that we basically set everything for API groups and resource and all the actions for the resources. In the next step, we need to define a service account, right? We create a service account with name of Jenkins-admin, and we created it inside the DevOps tools. Okay, the idea is like we want to create a separated namespace and just deploy everything related to Jenkins, including the Jenkins controller itself and all the pods as agents inside that namespace, right? And the reason for that is that probably in the future we also want to deploy other tools in this cluster as well, right? Because of that, it makes sense that we create an isolated namespace and just put everything in there. So the namespace in our case is DevOps tools. And then we created a cluster role binding and assigned all the cluster roles we just defined to the service account we created. As you can see, everything just assigned to every permissions provided here is just assigned to Jenkins admin. And also we need the persistent volume. I think the reason is quite obvious, but just to mention it, we don't want Jenkins controller to lose all the data on restarts. Jenkins is a system that might need several restarts. For example, after installing some plugins, you have to give it a restart to make the plugins fully functional and everything integrated. So in that case, we need a persistent volume just not to lose any data. And as you can see, nothing special is defined related to this persistent volume, quite straightforward. Storage is set to 50 gigabytes. In our case, I think it's more than enough, but you should just adjust it based on your need. And in the next step, and then we have the deployment definition itself. As you can see, again, there is nothing special related to this deployment. We want one replica. We want only one replica from it, and then we set the Jenkins latest for the image we want to have inside this deployment. We defined resource requests and limits, and you can see the limits in my case set to 2 gigabyte and a little bit less than 1 core, right? It's enough for make it working, right? But it should be adjusted in your case. I mean, the only thing that I want to do is just bringing up a Jenkins cluster inside Kubernetes and make it functional, right? I don't intend to just put it under the heavy load. So in your case, maybe you need to adjust these values, especially if you are trying to create a CICD system for your company. And then in the ports, we have two kind of ports. One of them is for HTTP and another is for JNLP. If you're wondering what is JNLP, basically JNLP is the protocol that Jenkins controller communicates through with the Jenkins agent. And we need it because Jenkins controller should be aware of the state of Jenkins agents and then terminate them and assign them tasks and blah, blah, blah. So there should be a protocol for them to communicate with each other, and that protocol is JNLP. And this communication goes through this port. And then we have two simple liveness probe and readiness probe just to make sure that the deployment is up and ready to serve. Nothing special. And then we assign some volume mounts and volume as well, and just assign it according to the PVC claim we just created. For the service section, as you can see, we defined a service attached to two specific ports. One of them is HTTP port, which will be used to access the web UI of the Jenkins controller, and another is again for JNLP port. And you can simply just skip this part. Actually, this is a customization for myself, and I can just give a hint what was the reason and then skip it. The reason is that maybe we have some cases that we want our Git repository, our remote Git repository, to start communication with Jenkins controller. So imagine the scenario that we want to something happen inside Jenkins controller if somebody merge code or somebody create a pull request inside Git remote repository. And there should be a way to start the communication. We have two options here, right? The first option is create a ingress controller and then attach the ingress to this deployment and service and call the endpoint for this ingress controller. For this purpose, we need to register a DNS. We need to register a new DNS, which I don't want to do, right? I just want to keep it very simple, and this is just an example how we can deploy a CI/CD cluster. So I don't want to go with this approach. And another approach is just by creating a service with the type of load balancer and get the external IP and then provide the IP and port to the GitHub or whatever GitHub repository you are using. So the reason for creation this service was just like that. You can simply just skip it. We don't need it. And the next part as well is like attaching an ingress to this service and the deployment. And again, the reason is that we want to access the Jenkins controller web UI through the internet. And because of that, we need an ingress controller installed inside our Kubernetes cluster, and then define a host for it, and then just route all the traffic for that host to the service and deployment itself. And this is a very simple ingress, nothing special for it. It just serve for the request with the host of jenkins.example.com and then deliver it to Jenkins service and port 8080. That was pretty much of it. There's nothing more. Very simple, very straightforward, and all provided inside the Jenkins installation documentation. So let's quickly deploy it inside our Kubernetes cluster. But first, we still can't apply this deployment inside our Kubernetes cluster, and the reason is we didn't set up our local kubectl to connect to the cluster, to the remote cluster. For doing so, there is a very simple way. Let's quickly have a look on Google Cloud Console. And then inside the Kubernetes clusters, as you can see, there is a primary which we defined in our Terraform code, and inside the primary cluster, we have an option here for connect, and it will provide you a command that you can just simply copy and paste and run it in your local machine, and it configures the kubectl, your local kubectl configuration, in a way that it can start communicating with the remote cluster. So let's quickly go through it, just copy it, and then go back to the VS Code and use its terminal, and then paste the command here. Okay, so apparently the kubectl is already configured. Let's define an alias for kubectl, and then get the node. Okay, seems good. So we are already connected to the remote cluster, everything worked fine, and we are ready to deploy the new deployment we created for Jenkins. Let's see, where are we? Okay, and then inside the infra, and inside the CICD, and then inside the tools, and then inside the Jenkins, and that's all. Let's create it. Okay, we have some beautiful errors here. And as you can see, it indicates that DevOps tools is not defined or is not created. So basically, if you can remember, we decided to just put everything related to our CI/CD pipeline into the DevOps tool namespace, right? And we didn't create it. And that's the reason we faced with this error, right? So let's quickly create the namespace. Namespace as DevOps-tools, and then redeploy everything. Yeah, and this time looks good. So let's quickly see what is happening inside our cluster. DevOps-tools. Oh, it's pending. We didn't expect that. Let's quickly see what's happening there. Scribe PO tools. Okay, and there is nice, insufficient CPU. Okay, if you remember from the last part, we configured the cluster in a way that we don't want to waste that much money or resource at all, right? So basically now the number of nodes inside the node pool is 0, right? And in case that Kubernetes is faced with some workload, it will auto-scale it, increase the resources, or create another instance inside the node pool, and then assign everything to it. Let's quickly give it a look inside the Google Cloud Console as well. So I would go for Google Cloud Console, and inside that, where am I? Yeah, there it is. And inside that, let's go to workload. And as you can see, there is a very beautiful error message here as well. Does not have minimum availability, but this is not something that we should concern about because Kubernetes is responsible to solve everything for us. So let's quickly go back to clusters and then to primary and check the node pools there. Okay, nice. And as you can see, there is a new node created inside our node pool, and we expect it to be deployed quickly. Let's go back to the terminal. And inside the terminal, we will get the pods again, and nice. As you can see, it's created already, right? And now Jenkins in the initialization part. Let's quickly see the logs related to Jenkins initialization. And DevOps tools. Okay, nice. Okay. It's in the initialization part, and it's already created one-time password that we should provide in the first initialization. So soon enough, we can see that the status of this pod is running and one ready of one, so everything works fine. Still there is a problem because we cannot because we cannot connect to the Jenkins web UI yet. Why? Because we didn't define any ingress controller so far, right? So for this purpose, we're gonna deploy Nginx ingress controller inside our Kubernetes cluster, and we are going to do so using Helm chart. In this case, Helm actually provides us the simplicity, so we go with Helm. So let's quickly check how can we actually deploy the Nginx controller through Helm. Let's go back to the browser, and then inside the browser, search for Nginx ingress controller Helm, and then go to the documentation of the Nginx controller, and as you can see, there is a repository that we should add here. Okay, let's go back to the terminal and add it. I previously added it, so I have it. I just give the Helm repo update. Okay, perfect. And then there is a rule that I always follow, and that is I always prefer to have all the Helm chart also available in the files, in accessible, let's say. And there is a reason for it, because I want to be safe against unwanted changes in the future, and also before applying any kind of Helm repositories to my cluster, I always go through all the values and the configuration to see what is happening after applying this Helm chart, right? So let's quickly just follow these rules of myself. For that purpose, I gonna pull the repository and use the ontar, because I don't want it to be as a tar file, right? Because basically when you pull a repository, in the first place, it will be downloaded as a tar file. It will be downloaded as a compressed, archived, right? And I don't want it to be like this. But before running this command, I think I am not in the correct directory, and I am right. Then I would go for infra, and then inside, let's say tools, and yeah, then I would pull the Helm chart in my local machine, and then perfect, I have the Nginx ingress. And then let's apply the Helm chart to my cluster. To do so, I will run Helm install, and name would be the name of this one would be Nginx ingress. And what is that? Was it Nginx ingress or ingress-nginx? Nginx ingress. Let's see. Yeah, there it is. And come on. Boom. Now we have the ingress controller deployed in our cluster. Let's see. As we see, okay, as you can see, there is a service for the ingress controller here with the type of load balancer, and it's pending for external IP. We need this IP, right? Because later, if it is the real cluster and you want to just provide it for your company or just addressing some request with it, you have to register a DNS query, a DNS record for it, right? I don't want to do so, but I can still leverage the IP this load balancer will provide for me. And the way I want to do so is just by updating my /etc/hosts file. So I can just point a specific host to this address and access the Jenkins controller web UI. Let's get the service one more time, and this time we have an IP for it. Perfect. And inside our hosts sorry, what's happening? Yeah, inside the hosts, I have the jenkins.example.com host, and I set the IP, and everything looks good. And let's go back to the browser and check if we have access to the Jenkins web UI or not. Okay, then inside the Jenkins, I would enter the hostname I just defined, and yeah, perfect. We have access to the Jenkins web UI, right? This is the administration password for the first initialization, and you can just grab it through the logs. Let's go back to the terminal again. And inside the terminal, let's get the logs. And inside the logs, there is a administration password, as you can see. And I will copy it, go back to browser, and just paste it here. Where is it? Yeah. Paste it here. And yeah, in this step, you have to define how would you like to create with the Jenkins plugins. Do you want to just select the plugins you want to be installed, or you want to go with suggested one? Just for simplicity, I would just choose install suggested plugins because it's simpler. You can manage all the needed clusters or redundant cluster later on in the Jenkins configuration. So for now, I just hit the install suggested plugins. And then in this step, it starts downloading all the required, let's say, plugins that Jenkins need to start working, right? We should wait till this steps just finish. Okay, nice. Now that we have all the required plugins installed, let's define a username and your password, and again repeat it, name and something like this, and then save and continue. It will ask for Jenkins URL, no problem with that. Let's continue with this one and start using Jenkins. Yeah, this is the beautiful user interface of Jenkins. Just kidding, I know it's ugly, definitely, but there is so much power behind that, right? And we want to use Jenkins only because of that power it provides for us. Just remember the idea. What did we want actually? We wanted to have all the Jenkins agents inside the Kubernetes cluster, right? So we have to configure the Jenkins in a way that it can bring up its own agents inside this cluster. We need to install a specific plugin, namely Kubernetes. Kubernetes plugin just simply provides the ability for the Jenkins to connect to Kubernetes API server and do things there, right? For instance, in the Kubernetes cluster, we have to go to Manage Jenkins, and then inside Manage Jenkins, we go to Manage Plugins, and inside the Manage Plugins, in the Available Plugins, we just simply search for Kubernetes. And where is it? Yeah, there it is. We want this plugin, Kubernetes, without any further part in the name. We don't want Kubernetes credentials or Kubernetes client or whatever. We only need Kubernetes plugin. And then choose install without restart. And it starts downloading and configuring everything it needs to start working. Just remember, after installation of this plugin, you need to have a restart in Jenkins, right? And it can all be done through the web interface as well. So now that we have everything successed here, as you can see, we just choose restart Jenkins when installation is complete. And by doing so, boom, Jenkins just got restarted, right? Let's go through logs to see what's happening. let's go back to the VS Code and use its terminal, and then again just following the logs. Yeah, as you can see, Jenkins is initializing right now. We have to wait until this process finishes. Okay, and now you can see the message that Jenkins is fully up and running. Let's refresh the page. Where is it? There we go. Let's refresh the page quickly, and yeah, we cannot access it. And what's the reason? Let's go back to the terminal, and inside the terminal you can get the pods, and as you can see, now it's ready, right? But in that time, most probably Liveness Pro failed because it just initialized and ready to serve, right? So let's go back again in the web browser to check, to give it a check, and we still don't have access. Yeah, we have access to it. And then we just enter the credentials just created, and let's log in. Okay, perfect. So the next step for us is to just configure the connection between the Kubernetes plugin and the Kubernetes cluster. The deployment is already in, right? So let's go to manage Jenkins once again. And inside that, this time we are going to manage nodes and clouds, right? And inside the manage node and clouds, we don't want to add any new node because we don't want to add any physical nodes or VM nodes or whatever. What we want to do is just assigning the pods as agents, right? So we go to configure clouds, and inside configure clouds there is a Kubernetes. The only reason that you already see the Kubernetes here is because you installed the Kubernetes plugin, right? So Kubernetes plugin basically is the component that provides the accessibility to any Kubernetes clusters, right? So we choose it, and then it will provide us a set of configuration. Most of the fields here already have predefined values. The point is, if you are going to use this controller, this Jenkins controller inside the Kubernetes, inside the same Kubernetes cluster that you want to bring up the pods as agents, you can simply go with all the predefined configuration, right? So in this part for Kubernetes, you don't have to provide anything basically. The only parameter that I want to provide for it is the namespace. Again, we want to set everything. We want to deploy everything related to this CICD cluster or CICD pipeline inside DevOps/tools namespace, right? So I just provide the name here, and no credential is needed because it is inside the Kubernetes cluster. Everything is okay. In case that you have a Jenkins controller outside of the Kubernetes cluster and you want to use the Kubernetes cluster only for just controlling the life cycle of pods as agents, in that case, you have to provide the Kubernetes cluster, the target Kubernetes cluster credentials, and the address for connecting to Kubernetes API, right? But in our case, we don't need anything basically. And let's test the connections. Hopefully it will be successful. Yeah, there it is. Connected to Kubernetes. So we are good here, right? What is the next step that we should configure? And that is Jenkins URL. What is Jenkins URL? Basically, pods should know how they can start connections between the Jenkins controller, right? And they read this URL from this specific field, Jenkins URL. What URL are we going to use? If you can remember, we just created a service for Jenkins controller and assign it to the deployment. And another fact is that everything is happening inside the Kubernetes cluster. So the only thing that I should provide here is just the URL for that service address. And that is just like this. And just to illustrate it a little bit more, Jenkins-service is the name of the service we just created. and then this is the namespace. It's a standard way for just accessing the service inside the Kubernetes cluster. And then let's see, what do we have? We don't need pod label for now, but what do we need is creating the pod template itself. Inside the pod template, we need an add pod template, and we need to provide a name for it. What is the pod template? Pod template basically is the template of the agent. It's the template of the pod that agent resides in, right? So let's name it as JNLP, because basically the first container that should be brought up and the main container of the pod, no matter how many containers lives in the pod, but the main container should be JNLP, because JNLP is the container that is able to communicate with the Jenkins controller, right? So we just name it as Jenkins, we just name it as JNLP, and then for rest of the configuration, we define the namespace as DevOps tools, and then the label. This is a very important part, because basically we assign the job to this specific kind of pods, this specific kind of agents based on labels, right? So if I, for example, set a cube agent here, and when I create the job, restrict the job to only run on the machines or the targets or the agents with the label of cube agents, Jenkins knows that, okay, I should deliver this job to the pods, right? So it's very important here. And next we have to add containers, right? As I just said, the very first container that should live inside the pod is JNLP itself. So I name it as JNLP, and for the Docker image, I just use the standard Docker image with the tag latest for it. And then the home directory looks good. I gonna just delete these commands inside the container because we don't need it. And yeah, that was pretty much it. Other configurations here as well. For example, if you want to assign some environment variable for the pods or for the containers, you can just assign it here. And then if you want to attach some volumes to the container, you can just go with it here. As you can see, there are several types of volumes, which would be quite handy in different scenarios. So you can, for example, create a config map as a volume, or NFS, or secret volume, or whatever you need, basically. And yeah, for the rest of the configuration, you can just check it out, but I think we are good here. I just apply it and save it. Now it is time to check all the configuration are correct, and we can really bring up a pod as an agent inside Kubernetes, and then just deliver a job to it. It runs the job, and then Jenkins controller should terminate it, right? So let's see how we can achieve it. Actually, we go back to the dashboards, and in the dashboards we click on the new item, and for the new item, let's say we want the name of the job be what should it be? Agent test, something like this. And freestyle would work fine for this case, because we don't want it to be complicated. We don't need pipelines or any script, so freestyle is good. After creating it, let's see. We have options here that should be checked, and that is restrict where this project can be run, right? And as you can remember, this is the label that we defined in the pod, right? So if you provide the same label here, basically Jenkins deliver this job to the pods. So let's say it was cube agent. As you can see, it's actually suggesting it as well. And then we go to the build step and create a shell execution and say, sorry, hello, I am working, and that's all. Apply and save. Okay. And now we can go back to the dashboards, and as you can see, we have a job here that never ran. Last successful, not applicable. Last failure, not applicable. So let's run it actually. But before that, I need an eye. Let's go back to the terminal. where is it? Yeah, there it is. I need an eye to watch the pods because I want to be notified if new pod actually created and after the execution it's terminated, right? Let's see. Let's say watch kubectl get pod and DevOps tools. And okay, now let's go back to the web browser here and then hit the play button. Okay, as you can see, something is happening here. So let's go back to the VS Code itself. As you can see, there is a new container, there's a new pod here, right? And it's running, it's a running status, and in a few seconds, based on the job, it should be terminated, and yeah, it's working as expected. Let's quickly go back to the web console and see all the outputs and what's happening there. And by giving it a refresh, we can see the task already success. And last success was 18 seconds ago. Let's see the output of the pods by clicking the number of builds here and go to console output. And as you can see, the first part always is all the configuration we just created in the configuration of Kubernetes plugin, as you can remember. And then there is a shell script here, shell execution, let's say here, and that is echo hello I'm working, and hello I'm working appeared here, and everything finished successfully. So we already created a real pipeline, right? And a very simple one actually, but the point of this pipeline was to only prove that now Jenkins controller is able to create new pods, consider them as agents and assign some tasks to them and then just terminate them. And that was the whole idea. In the next step, let's create a real pipeline and see how Jenkins controller can manage it.
Okay guys, I cannot believe, but apparently we already exit from the standard time for this video. So thank you so much for bearing with me. And if you like the video, please hit the like button and also do the subscribe and share the link with the friends or colleagues that you might think they would need it. The rest of the creation of this CI/CD pipeline will be illustrated in next upcoming videos. So please provide me with the comments if you have any question and any suggestion. I would be more than happy to see that. Stay tuned. Ciao.